Hey, do you guys know about the Blind Deaf and Mute Challenge? What if instead it's cooking, we're driving, and a maze? Well, that is what we're wondering. What would happen? Do you trust your friend? Or do you not? You guys can communicate with each other. Or not? Well, that's what we're trying to figure out. And also have fun. Well, here it is. Century Drift.
And now we actually need three things really. One, we need a little tiny car that can drive around a whole obstacle course and be able to sense whenever it collides with something. Second, we need a way to drive that little car, make it really fun, and be a platform for all sorts of sensory feedback fun. And finally, we need a way to track that little car and track that little car across a whole maze or obstacle course. More on that later. For the Roomba, we actually modeled and 3D printed everything. And because of that, we initially planned for it to actually be like a little car, with 4 wheels and a whole rack and pinion steering system, but that was overly complicated. We actually needed it to do 3 things. We needed it to be as small as possible. We needed for it to be able to turn in place and finally sense collisions. Because of that, we ended up actually going with just 2 stepper motors, left, right, so actual 10 controls, but then via program, we'll actually just behave like a regular car. For collisions, we initially planned to add buttons are all around the car, or like a whole metallic film here. So whenever it touches anything, it completes the circuit, collision detected. But that was sort of overly complicated. So to simplify everything, we went for this little guy. Here, this was just a joystick, right? What happens when you touch a joystick or it hits something? It collides. So this little bad boy becomes the whole thing. Collision happens, the joystick reflects, and collision is detected. So how do we go about driving the car? Well, how do you do it in real life? Just like that. Steering and brake system? Perfect. We're taking that. In order to drive the car, we have a whole steering system right there. It's using a whole set of gears and everything like that with a potentiometer attached at the end. We initially wanted to connect it directly to a DC motor with a rotary cord at the end, but that's a bit expensive and overly complicated. We just end up settling for the potentiometer system. And to do the whole throttle and brake system, this is the solution. Or with this, you could actually press them. Throttle, we initially wanted for it to be binary, so just on or off via buttons, so make everything simple. But we thought providing a whole analog input would make the whole experience more lifelike and less jittery and more smooth, really. And to wrap it all together, all steer, brake, throttle, all seat together, and boom, you have a whole mechanism. So how do we go about tracking the little car? We initially thought of using ultra-wideband transmitter and receivers, but that was overly complicated, expensive, and actually unreliable. So what do we end up using? Cameras. You see, at the end of this joystick, you see this little arrow. In the final product, this thing was actually colored, and we're tracking that color with a whole camera vision system. After tracking that color, we can basically select the location on the map, the maze, or the obstacle course of where it's tracking it to, and detect the distance. Speaking of maze, how do we do that?
Thanks, Pascal. To answer your question, the final maze is a 1.2 by 1.2 meter square made from 6 giant acrylic paints, 3D printed parts, balsa wood. And did I mention 3D printed parts? Like, a lot? Anyways, we ran into a problem. To simply put it, the maze, Suez Canal, mini car, ever given. So, can you guess what our solution was? That's right. If you guessed C, then you're correct. The moment we flipped the maze though, we ran into another problem. Not a surprise. The acrylics were too heavy for it to just be supported by friction fit wood walls and plastic poles. So I did what everyone does when faced with a problem. I opened Onshape and started designing. First came the Ferbs. I call them Ferbs because they look like Ferb of Phineas and Ferb. Their main job is to stop the whole maze from collapsing. Then came the wrench supports, and then the drawer connectors, and you guessed it, more Ferbs. Eventually, it reached to a point where every solution came from 3D printing. Special shout out to Pascal and Kichu. The end result, a fully modular maze. I probably used around 6 to 7 kilograms worth of filament. Were there better ways I could have done this? Definitely. Does it look cool though? Hell yeah, it does. And does it work? Yes, it does. Now, what about the buttons that are around the maze?
Buttons? Yes, this is where communication actually begins. The buttons are the navigator's way of giving direction to the driver without speaking. In Sensory Drift, there are 4 directions: left, right, forward, and reverse. Each 4 buttons is labeled with a character A, B, X, and Y. However, at the start, the navigator doesn't know which character represents which button. Given that the driver can speak, they will describe the vibration they feel and give the feedback to the navigator. Based on that feedback, the navigator gradually figures out which buttons represent which direction, which one means left, right, reverse, and forward. When the navigator figures out the directions, it is more clear of which routes they should be going. As they can see where the car is heading to in that maze, now they can stomp on the button that corresponds to the car's right pathways. For example, if they can see the car that needs to go to left, they will stomp on the left button, so they will need to stomp on the B directions for the driver to feel the vibrations, so the driver can actually turn to left directions. So instead of using words or visual instruction, the button become a shared language between the 2 players, the driver and the navigator. They turn simple movement into touch-based communication. Now, how does the vibration actually works?
The vibration is located in the car itself, in the seat, and also the pedals. So how do we trigger the vibrations, you ask? Well, there's one on the mini car. When you hit something, it vibrates. Also, do you remember the buttons around the mazes? Yes, if you press those buttons, it will trigger vibrations in the seat and also the pedals. So how do I come up with vibrations? So at first, I was thinking of using speakers. You know how speakers have subwoofers? And that'll be amazing for vibrations. Yeah, I want to do that, but it is very expensive. So what's the next best option? Motors. At first, I was using the small motors and they don't give enough power. That is very unfortunate, but I found this motor. It's bigger, but it gives more power, 12 volts, and that actually gives enough oomph for vibrations. It was very fun, very challenging in some way. Well, thank you for having us, and see you later.